Okay, so last section we're going to look at this week is 1.5, which is on solving what's called a literal equation. So the kind of equations we see today aren't going to have as many numbers in them. We still do things exactly the same. You're just going to see less numbers. That's basically the idea. So the equations that we look at are going to have 2 or more letters. Sometimes they might have 2, sometimes they might have 3. Might even have one with 4. Anything in the interest formula? Yeah. But we'll talk about what you're going to do with them. Obviously, if there's not as many numbers, one of the steps might not be to find a number to answer. Like normally we write x equals 3 or x equals 7. You might not be writing stuff like that for some of these. You might not actually be finding a number. What we're going to be doing is rewriting these equations. So basically we're going to take like something that's given to us and we're going to just rewrite it a different way. And what it's going to tell you, the way it's going to tell you to rewrite it is it's going to ask you to get a particular letter by itself. If you've ever done like y equals mx plus b, yep, a lot of times we always get y by itself. That's kind of like what this is getting us ready for later. How to get a certain letter by itself.
So guys, that stuff that's highlighted is what you want. If you have 2 blanks on your on that first part of your guided notes, that's what you want to write in.
Yeah, just what's highlighted. So we're going to give you guys some specific formulas in a little bit. There's like a formula for how much interest you make in a bank account. I think how to change a temperature from like Celsius to Fahrenheit. But we're going to start out with just a formula like this that has no real
It's going to tell you what to solve for.
Yeah, it's not anything special. It's not a word problem. It's not related to like money or time. It's just a formula Mr. Roy and I made up. And it says x plus y equals 7.
So guys, on your guided notes, it says solve the literal equation. Then it's a blank. Then it says, on yours it says for y, just cross out the y and put x. And then right on where the blank is, you can write in x plus y equals 7. So just change, the only thing you have to change here is change the y to an x.
So if you look at the equation right now, what's by itself on one side? Yeah, the 7. Okay, they don't want the 7 on one side by itself. They want the x by itself. So when you're done, your answer is going to look like this. X equals is going to be by itself, and then we're going to have stuff on the other side. All right, so let's look at the side where the x is. Is the x by itself right now?
Yeah, no.
Is that the only thing on that side? No, what's there that's preventing the x from being by itself? Yeah.
Y.
Yeah, positive or negative?
Positive.
Positive y. So that's our goal. We want to get rid of positive y.
And guys, I know some people said that x has nothing attached to it, but you could say it's alone, but it's not isolated. Isolated means it's by itself on one side and equal sign, with nothing else on that side and equal sign with it. So it's not isolated yet.
Alright, so we've got x plus y equals 7. How would I move a positive y to the other side? And it would be exactly the same step as if it was this. How would you move positive 3 to the other side? Okay, the only difference is instead of saying do this to 3, you're going to say do this to y. What would you do to y? Jacob?
Make it a negative?
Okay, make it a negative. And what operation is that? Is that add, subtract, multiply, or divide?
Subtract.
Yeah, good job. We're going to subtract on both sides. And what would we subtract? We're going to subtract the y. Just like up above, you would subtract the 3. We're subtracting the y. So it's really the same idea. Nicole, plus y minus y. What happens there? Cancels out. It's gone. Alex, what's on the left-hand side now? Just x. That's exactly what we wanted. X equals, and now we're going to have a formula on the other side. Ellie?
7 minus y.
Yep. x equals 7
Yeah,
minus
basically,
y.
Mr. Hager has it written vertically, the 7 minus y. Basically, it is taking that and writing it horizontally or across. Because you can't combine those two things. So you're just going to take what's written there vertically and write it horizontally.
Yep, don't try to combine the 7 and the y because the 7 doesn't have a letter. If the 7 had the letter y with it, then you could. But it's just a number. And that's it. That's all you're going to do. Any question on what we did there? So, what's that?
That's it.
That's it.
That's what we're going to practice today. Now,
And then that was like that's like a one step literal equation.
one step.
That's like a mistake. It showed you like x plus 3 equals 7. That's a one step equation. That's a one step literal equation. Now, if there was like something attached, we had to solve for x, and there was something attached to it, there'd be another step.
Okay, so now when we finish this one, this is the goal. Y equals something like that. Now, if you're familiar with y equals mx plus b, eventually we're going to do that. For today or for the test, it's not really super important if they write it in that order.
No.
Because we're not always going to have y by itself. We might be getting x by itself, right? Later on, it will always be y, but that's when we talk about slope.
And guys, on your notes, for example, too, just make sure you change it says x there. Just make sure you change it to y.
Okay, so I just put that there because that's the goal. That's what we're trying to get eventually. So let's write down 8x plus 7 equals negative 5x plus 7y. All right, so let's look at it. Is the y by itself on one side of the equal sign? No. Can somebody tell me something that's over with the y? There's a lot of stuff that we're going to have to get rid of. Matt?
Negative 5x.
Yep. We're going to have to get rid of the negative 5x. And that's actually the first thing we get rid of. And then what else do we have to get rid of? We'll do this in the second step. Yep. The 7. Okay, we got to get rid of that positive 7. So I'm going to start with what Matt said, the negative 5x. And the way I think of it is pretend like the stuff that's really close to the y, it's being protected by the y. Right? If you're closer to someone that can protect you, they can do a better job. The 7 is very close to the y, so it's really being protected. The negative 5x is further away, so the y can't protect it because it's farther away. So we get rid of the things farther away first because they're not protected, if that helps. So negative 5x. How would we get rid of that and put it on the other side? You said? Yeah, plus 5x. Plus 5x.
When you're doing that, just if there's a x on the other side, match it up to the x on the other side. If not, just bring it over.
Yep, that's important. You got to make sure you line it up if it's there. So the negative 5x plus 5x is gone. But not everything's gone on the right. Brady, what's still on the right side that I didn't do anything to yet?
Plus 7y.
The plus 7y. Yep. It's the only thing that's there now. Now, Ryan, I've got 8x plus 5x. So if I add 8 and 5, what does that give me? 13. And we just have to remember that what was with them originally. It's not just a 13, but a 13x. Yep. So 13x plus 7 didn't do anything to it. Okay, are we good? Is y by itself? No, Jacob said no. There's still one more thing there, and I think Gigi told us earlier, it's that 7. So now we've got to figure out how do we get rid of that 7? Yeah, Jacob?
You had to divide the 7.
Yeah. Perfect. We're going to divide by 7. And now when you divide, just do it like this. The whole thing. Okay? I know it's kind of weird when you add and subtract, you only put it under one thing. You don't like put the 5x under both. We did that correct. When you divide, you have to do the whole thing. Okay? Just kind of the way it works. So when you divide, the whole thing. So divide by 7. Divide by 7. On the right-hand side, it's gone. And now, what am I left with on the right? Ellie?
13x equals y.
On which side?
On the right side? Wait, no, left side.
That's the left side. What's on the right side?
Y.
Y.
So would it be 13x plus 7, or would it be...
So on the left-hand side, we're just going to leave it just like that. 13x plus 7 divided by 7. Now, if you're wondering, well, why can't you reduce it? Because with division, if you wanted to reduce it, 7 would have to go into that number, and that number. It doesn't go into all of them. If you had, just to change it a little bit, don't change it on yours, but just look at this. Does 7 go into 14?
Yes.
Does 7 go into 7?
Yes.
And does 7 go into 7?
Yes.
Then yes, now you can reduce.
That one you can.
7 goes into 7 once. 7 goes into 14 twice. 7 goes into 7 once. If it doesn't go into all of them, you can't reduce.
So the number on the bottom has to go into both, however many numbers you have on the top. Use the question.
So we'll just do like that 13x plus 7, like dividing by 7.
Yeah, 15x plus 7 divided by 7y, that's fine. Yep, that's perfectly fine.
Yep. Does anybody write it different than that? Anyone have a different way that they do it? Sometime when we study slope and y-intercept, some people might say, they might do it like this. They say, oh, I'm going to divide by 7. Here, here, and here. Does anyone ever do it that way? Yeah, if you do it that way, that's perfectly fine too. I don't want to confuse people, but that's perfect, Donovan. And that's actually what we're going to do more later on. Yeah.
And you guys, some other math teachers get more into like, they have you like, they might be like, put parentheses, and they do some crazy stuff with this. Again, our big thing with this is as long as you can get y by itself, you know, you have to, there's a number attached to y, divide, that kind of stuff. We're not going to go any more crazier than this with these kind of problems. Then obviously, we're going to use some formulas and move some letters around. But other than that, we're not going super crazy with these literal equations.
So Donovan, if you had that, I would accept that on a test as well. That's perfectly fine. If people did what's on the left, that's perfectly fine too. All right, I would just stick with the way I did it on the
Hey
left.
guys, when Mr. Hager wrote on the right there, like y equals, that's perfect. If we're doing slope, that is slope-intercept form, that's perfect. All right, but we're not quite there yet, so if you left it like it was on the left-hand side, that's perfect, that's fine.
All right, so let's look at this one. You guys, I think it's already printed on there. So it says that you own a rectangular piece of land, right? And it's 500 feet deep. So that's how, is that labeled on there?
Yeah.
Yeah, 500 feet. It has an area of 1,000 square feet, all right? So that's the same picture that you guys got. So on the right-hand side, that's the road. And usually they call the land that you own right along the road, that's like the front of your house. So they call that the frontage. That's how much land is along the road. So it says to pay for a new water system, the town or whatever is going to charge you $5.50 for every foot of land you have along the edge of the road. So basically, we've got to figure out how much land do we have right there. That's like the width of your property. All right, so 500 feet is how far back your property goes. W is the width. So first thing it says, find the width of your property. Okay, how much property do you have along the road? And then how much is it going to cost you to put in a new water system? So we got to do A and then B. So in this original part, can somebody tell me something that's important there? Something we're going to have to deal with? Yeah.
500 feet deep.
Yep, so that's important. Your lot is 500 feet deep. All right, what else? Savannah?
It has an area of 100,000 square feet.
Yes, that's important. Area of 100,000 square feet. So we're going to need a formula to do this problem. All right? Look at the shape of the land in green. What shape is this property? It's a rectangle. And they're giving us the area of that rectangle. So the formula that we're going to have to use to find the frontage is going to have to do with the area of this shape. So that's the formula we need to start with. So what's the formula for area of a rectangle? Yeah.
Can I go to the
Sure. Can you tell me the formula for area of a rectangle?
Length times width.
Nice. Yeah. Area is length times width. Let's look at that formula and see, is there anything in that formula that we know? A, L, or W? Okay, we've got to know something or we can't use the formula. Ellie?
Well, we know the area of the frontage and we know the width.
So we know the area. That's right there.
And we know the width because it says that it's 500 feet across.
So it says it's 500 feet deep.
Well, yeah. Okay, so we don't know the width, but we know width is there.
So we don't know the width, but we do know.
That it's somewhere in the problem.
No, the width isn't in the problem. That's what we have to solve for.
Oh.
Yep. We know the length. That's the length.
Oh.
The length of your property, in this case, is how far back it goes, how deep it is. So we know the area. We know the length. What's the one thing we don't know? Yep, not it. The width. So what are we going to do with the 500 and the 100,000? What do you think we're going to do with those two numbers?
Divide.
Well, before we even do any arithmetic, we got to plug it in. So let's plug it in. Area, what do I plug in for area? 100,000. What do I plug in for length? 500. What do I plug in for width? Yeah, we just leave it as W. We don't know what it is. And you can use X, you can use any letter, but if I use W, I'll remember, oh, W is width. And now, Donovan, you were telling me the next step. How do you get W by itself here?
You divide by 500.
Yep. Divide by 500. Divide by 500. That's gone. Now we'll just use our calculator. Okay, 100,000 divided by 500. Divided by 500. So we get 200. What's the 200 again? That's my width. And what do they call the width in this problem? They call it the frontage. That's.
It is measured in feet, you're right on.
But yep, that was my next question. It is the frontage is measured in feet. Okay, so the length of your property along the road is 200 feet. Now, how much are you going to have to pay for a new water system? So now we've got to use this. The city charges you $5.50 per foot. So how am I going to figure that out? The front of my property is 200 feet, and I have to pay $5.50 for every foot on the front of my property. Yep.
Multiply 200 times 550.
Yeah. So for part B, we're going to take 200 feet. That's the length of the width of the property, and you got to pay $5.50 for every foot. So for the city to put a new, water system or something?
Yeah.
Yeah, put in a new water system. They're going to charge you. It's expensive stuff. It's going to be $1,100 to replace all that pipe underground. Okay, $1,100. Okay, so that one was a little tricky because they didn't tell you the formula to use, right? You kind of had to know, all right, they gave me a formula for area. My shape is a rectangle, so what's the formula for area of a rectangle? And that's the formula you need to use. Any questions on how we figured that out? Okay, if it's a formula that's more complicated, we'll give you the formula. All right, so or we'll at least tell you, put it on your reference sheet, and you can use it on the test. All right, but area equals length times width. That's one you got to know that one. Okay, so here's some common formulas you guys are going to fill in on the back of your reference sheet. Okay. in those 3 boxes. So you should see 3 boxes at the top. Okay, so the first one is for temperature. Okay. Has everyone heard of Fahrenheit and Celsius? So the US uses Fahrenheit. Pretty much every other country in the world uses Celsius. Yeah, Celsius is easier, right? Water freezes at 0, boils at 100. You don't get these weird numbers like in Fahrenheit, water freezes at 32 and boils at 212. So it's kind of odd numbers to remember. 0, 100, that's easier.
Why do we have Fahrenheit then?
Because the US is stupid.
Yeah, the US is a little stubborn. Like, same thing with feet and miles.
Yeah.
It's very weird numbers. It's like 5,280 feet in a mile.
The other one is.
But metric is easier because you just have to remember, oh, it's always a 10. Like there's, or 100 or 1,000. It's nice numbers. We have weird numbers, like 3 feet in a yard. It's just...
I think the US is like the embodiment of we sound smarter than we actually are.
Sometimes I think that's true. Yes.
Yeah, we use all these big numbers. How come they're tens?
So to convert a temperature from Celsius to Fahrenheit. Okay, this is something like if I'm on vacation and I'm in a country that uses it, I try to do it in my head real quick, because if they tell me it's going to be 30 out, I'm thinking, all right, 30 Celsius, what does that really mean Fahrenheit? Or the other way around. Okay, this would kind of be useful if somebody was coming over here from Europe and they're used to Celsius temperatures, and they say, whoa, they tell me the temperature today is going to be 75. What does that mean in what I'm used to using?
That's pretty hot.
They could use that temperature. They could use that formula to figure it out. So in that box, you want to write Z equals 5 ninths, and then in parentheses, F minus 32. Okay, so we're gonna do an example. I think we'll get to one that has temperature.
Not sure.
No. Okay, this is a formula.
I know we use one of those mistakes, I'm just not sure
Which one? Okay, so here's a formula for.
It might be
Interest.
interest rate time.
Okay, so this is a formula. Like if you put your money in the bank account and you make interest. Or if you have a loan, like a car loan or a house loan, you have to pay interest. This is a simple formula, that's why it's called simple interest, to tell you the interest you would pay. Now, technically this is not really a formula our bank would use. This is the simple interest formula. The real one is a little more complicated. But we use the simple one. I equals PRT. I is interest. And if you're putting money like in your savings account, P is how much money you have in your account. Okay? It's what's sitting in there. R is a rate, and the bank usually tells you what they're going to pay you. Or if it's a loan, what you pay them. So if you make like, on an interest rate now for a savings account, it's probably like 0.1%. It's not very much. But back like 30 years ago, interest rates... It could be up to like 15, 16%, which was crazy. So great time to make money in a savings account, really bad time to borrow money if you need to buy a house. Okay. So R is the interest rate. Now it says there in decimal form. So can anyone tell me, if you had 12%, how would you write 12% as a decimal? Yeah?
Was it 0.04?
Not quite. Think about, what's a percent always out of? Like when you get a test. Percent is always out of 100. So if you got a 12% on a test, what that would mean is if the test had 100 questions on it, you got 12 of them right.
Oh, wow.
So now if you divide that, 12 divided by 100, 0.12. Not, what you gave me was 1.2%. This is 12%. It's a little different. You just end up moving the decimal place 2 places to the left. Okay? But if you ever forget that, just think of it as, oh, divide by 100, which just moves the decimal 2 places to the left. What if I had 8%? What would 8% be as a decimal? So your decimal place is right there. Yep.
Point to right.
Exactly. You move it 2 places. 1, 2. Whoop. Gotta fill in a spot right there. 0.08. Okay. So that's your rate. And then your time is how long you leave the money in the account. Okay. If you have a savings account, if you leave it there for 2 years, you make more money than if you only leave it there for 1 year. Okay. What we're also going to assume is if we ever have a problem like this, we're going to assume the interest rate never changes, which isn't really true. Interest rates can change every month. So if we had to do that, it gets more complicated. So if we have an interest rate, it's going to stay the same all the time for that loan. Okay, so that's your interest formula. And this one is the distance formula. Distance equals rate times time. So it involves 3 things. A distance. So like if you're driving somewhere, how far did you go? A rate. A rate is how fast you're driving. Now, do you normally drive at exactly the same speed when you go somewhere, the whole trip? No, the rate normally changes. But what we're going to do to make it simple is just assume the rate stays the same. Okay, so if you drive somewhere, we'll just assume maybe you set cruise control, you're on the highway, and there's no other traffic. You just stay at the same speed the whole time. And then the time, that's how long you've traveled. Okay, so we'll take a look at kind of rearranging one of these formulas and then plugging into it. So the bottom formula has 3 letters. The one above it has 4. I, P, R, T. And then the one above that one only has 2. C and F. So sometimes they have 2, sometimes 3, sometimes 4. They could have more, but not in the ones we do. Okay, that's the most I think you'd ever have. Okay, so the first part of the problem here says to take the distance formula. So let's write that down. What's the distance formula? Yep. D equals rate times time. And the way that Yusef gave it to me, the way I gave it to you, is D is by itself. What letter do they want by itself? Okay.
Rate.
Yeah, rate. They want R by itself. So when I solve this problem, am I going to have this part right here? Am I going to have a number for the answer? No. All I'm doing right now is rearranging letters. Maybe they're going to ask me to do something next with numbers. But for now, there's no numbers in the whole thing. So we want to get R by itself. What's preventing R from being by itself right now? Yusef? The T. So we got to come up with a way to get rid of that T. Put it on the other side.
And it says it's R times T.
So how would we get rid of the T? We're not really getting rid of it, we're moving it. How about Natasha? Do you have a guess at how we would, Mr. Roy kind of gave you a hint. He said right now it's R times T. How would we move it to the other side? Do you think you would add, subtract, multiply, or divide? Divide, yep. You're going to divide because it's times, and the opposite of times is divide. What would you divide each side by? T. Perfect. We're going to divide by T. We're going to divide by T. T's are gone. And now the only thing on the right-hand side is R. And Nate, what's on the left side right now?
D divided by T.
D divided by T. There you go. There's your formula. Is that different? Like, is that a different formula than the first one?
Yeah. Yes.
Okay, it looks a little different, but does it use the same letters?
Yeah.
Yeah, all we've really done is we took the original formula and we rearranged it. It's not like we invented something new. We took what we already had and just wrote it a different way. Did you, Mr. Roy, did you have something to say?
No, I'm saying, if you scroll down and see, they have a spot where it's on there, notice it says R equals, let's write R equals D over T.
Yeah, you could have just put that right there.
That way it's not written with what it equals at right one when it equals at the beginning.
So now we're going to take that formula and we're going to do something with it. Okay? They're telling me I travel 310 miles. So in terms of a D, an R, or a T, which letter do you think the 310 would be? So yeah, that's my D. So my distance is 310 miles, and it says you're going to drive for 4.5 hours. So we've used D, we're down to T and R. Melanie, which letter do you think 4.5 is?
T, because it's the time.
Yeah, T. T, because it's time. So now the question is, if you drove 310 miles in 4.5 hours, how fast were you going? Well, here's the formula right there. It says that your speed is equal to your distance divided by your time. Your distance divided by your time. What's that?
You just use the calculator.
Yep, you just use a calculator. 310 divided by 4.5. So we're just going to round it to 68 point. If I round it to 1 decimal place, what would that be?
69.
Oh, well, 68 point. What would be my decimal?
It's 6.888.
Yep. Yes, 68.9. So it's about 68.9. Now, it's a word problem, so we need a label on that. What was the unit on my distance? Brady? Yes, distance was miles, time was hours. That's miles divided by hours, so we write miles per hour. You can write it this way, miles per hour, or some people write MPH, same thing. You're driving about 68.9 miles per hour. Any question on rearranging the formula? That's the literal equation, and then using it to solve the problem we have in the board. Maybe you got one more?
Yeah.
Do you want to?
I'm going to say that. And guys, this one is not asking us to solve for any letter first. We can just go ahead and just use the formula. Alright, so you deposit $5,000 in an account that earns simple interest. After half a year, the account earns $162.50 of interest. What is the annual interest rate? So first off, I have to identify the formula that I want to use. So go back and look at your notes. What formula do you want to use, Ellie?
Simple interest.
Which is?
I equals PT, RT.
I equals PRT.
I added one little thing at the end, and this isn't going to affect anything to the very last step. What is the annual interest rate? And I'd like you to write the answer as a percent. Because that's how most banks, that's how anybody tells you an interest rate. It's always a percent. Okay? But don't worry about that till the very end.
So I is going to be what? What's I stand for?
Interest.
I is interest. Alright. P stands for what? How about Paige? What's the P stand for? Principal, right? What does that mean?
Is that Mr. Brown?
I was gonna say you read my mind.
Sorry. Corny joke.
What does principal mean, guys?
How much money goes in?
Exactly, the amount of money you're putting in, right? What are you starting with, right? The amount you put in, the amount you deposit,
So
right?
500 would be the P.
R is going to be the rate, which in this problem we don't know. And then T is what? Time. As we'll go through. So, like Ellie just said, I'm going to circle the 500, and she said that is going to be my what again?
P.
That's my
Principal.
That's my principal because it's depositing, right? That's what I'm putting in. All right. Next thing I have there is what's the next? If I'm reading right, what's the next number, Joe, that I come across?
1.5.
Half, right? Half is going to be for what? Is it going to be, we already used P. Is it going to be the R, the T, or the I? The T, right? Time. So I'm just going to circle it, put a T. How about, Catherine, what's the next number I come across as I'm reading the problem? Well, I just finished. Half was this number, right? What's the next number I found? 162.50. Okay, perfect. Matt, what does that stand for? All we're left with now is the I or the R. It's the interest rate, it tells us. So now I know what I can plug in. I want to use the same exact formula and just plug in numbers. So I know what I stands for. Chris, when I set it up, here's my equal sign. On the left, what number am I going to put?
162.5.
162.50. Yep. That tells me the interest. What's the next thing I'm going to write, Nathan? I just did the 162.50 because that was the interest.
5,000.
5,000. That's my P, right? I already labeled it. 5,000. I did that. What's the next thing I'm going to write, Nicole? So I've done the I. I've done the P. Now I'm at the R. You're kind of worried, right? Because there's no R on the problem, right? What can you write? What can you write?
R.
Let's write R. Keep it. You could write X if you wanted to, but let's keep it consistent. Let's use the letters that they're giving us. I'm just gonna put R. Because guys, when we do these, there's gonna be one letter we don't know, because that's what we're gonna solve for. So in this case, it's R. The last thing I want to write is what? Say, can I write half for this? Is that okay?
For T?
Yes.
Yeah.
Okay. This is half of me. I didn't know if I could write that. All right. Cool. So I'm gonna use some parentheses over here just to make it look a little bit nicer, so it's not all crunched together. So on this left-hand side, the 162.50, nothing's gonna happen yet. There's nothing I can do. Can't do anything yet. On that right-hand side, there is something I can do. What can I do on the right-hand side? Mary?
You can multiply the 5,000 by half.
Yeah, 5,000 by a half. If I wanted to do that on my calculator, I could do let's clear it. I could do 5,000 divided by 2. 2,500. I can multiply these two things. Sign up. Oh, I screwed that up, guys. I'm sorry. Don't write that. It should be multiplying. Sorry about that, guys. We got 5,000 times. We can do it as a decimal. 0.5. Oh, I'm still correct. Doesn't matter. Am I good with staying?
Yeah.
Okay. Sorry, guys. I don't know why I thought I did that wrong. I did multiply anyways. We're good. I multiply, so I get 2,500. But what's still left? I haven't done anything with it. Matt?
The R.
The R, right? Almost done. One more step, and I'm done. There.
Divide the 162 by 250.
Yep, 2,500. That'll cancel out. This will leave me with R on this side I can use my calculator. 162.50 divided by. So I got 0.065. Right? Now, like Mr. Hager said in the original, right? I'm going to scroll up just a little bit. He said, what is the annual interest rate as a percent? All right? What do you think, Mary? 6.5, right? Because again, before, Mr. Hager gave you, he said 12%, right? And he wanted you to make that a decimal. So if I think of 12, even though it's not written there, the decimal for 12, because they have 12, if I did this regular 12 as a decimal, it'd be 12.0, right? Any whole number as a decimal would be 1.0, 100.0, whatever. When I want to make it a decimal, I'm going to go, it's a percent, I want to make it a decimal, I'm going to move it 2 to the left, 2 decimal places to the left. When I want to make it, in this case, when I want to make it, this is a decimal, I want to make it a percent, I move it 2 to the right. I think of it like this. If I'm going at decimal D2P, decimal 2%, I'm going from decimal 2%, I'm going 2 to the right. If I'm going percent to decimal, I'm going 2 to the left. Up here, I'm going percent to decimal, so I went 2 to the left. Down here, it's as a decimal, I'm making it a percent. I'm going 2 to the right. And like, be 6.5%. Again, that's kind of like a hidden little piece, because it's not something that we're really like focusing on this week, being able to change decimal to percent, percent to decimal. It's something you have to know. This can be helpful, but again, you might just know how to do it. Okay? So that's it for that stuff. Alright? Far as tonight. Alright? Worksheet. I think there's 6, 7 problems, something like that. 5 of them are what we did today, and there's one absolute value, and there's one equation with distributed property. All right. Remember, MCAS review day tomorrow. First half of class, we'll work on the MCAS problem. Second half of class, we'll put some problems up on the board. We'll do some review. All right.
Guys, make sure you bring your Chromebook tomorrow.
Remember, guys, test on Friday. That test and the test from last academic week, we'll use those and all the homework we've done up until Friday for your progress report. All right? You'll get your progress reports next Friday, probably.
Not this Friday, so like next academic.
When you're in shop.
Oh.
When you're in shop next Friday, probably maybe like period 7 or something like that. When you're in shop. Remember, like I told you guys at the beginning of class, the reference sheet is up on Google Classroom. Alright? If you guys have some time now, if you want to print it out now, that's fine. But it is up on Google Classroom. Remember, like we said, progress reports close on Friday. And now we're not going to do it right now. So guys, you have some time if you want to print